I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see some basic concepts of unsupervised learning. First, see some introduction about this unsupervised learning. This unsupervised learning is a type of machine learning, all you know that, where the model learns patterns from input data without using the labeled responses. The main objective is to explore the structure or the distribution of data to uncover hidden patterns, clusters, relationships, etc. This approach is particularly useful in cases where labeling data is difficult or expensive or subjective. Unlike supervised learning, where the goal is to predict an output label, unsupervised learning focuses on understanding the underlying structure of the data itself. So, we'll see one example. If you are looking into this example, this is the flow of the unsupervised learning. If we are giving the raw data like this, we will not be labeling the input data. What will happen? The algorithm will segregate according to the structure it will be splitting. So this unsupervised learning, the process begins with the raw data that is completely unlabeled. This means that there are no predefined categories, classes, or outcomes associated with the input. The data could come from various resources or sources such as image, sensors, readings, text logs, or customer purchase histories. Often, this data is high dimensional and unstructured, making it challenging to analyze using traditional methods. And for that only we are using the algorithms. The core of unsupervised learning lies in the algorithms that identify hidden structures within the data. Common techniques include clustering algorithms like k-mean or DB-scan, etc., which groups similar data points together, and dimensionality reduction methods such as principal component analysis or TSNE, which is simply data visualization and analyze by reducing feature space. Association rule mining, like the a priori algorithm, is also used to find relationship between variables in large data sets. And what we are getting the output, the final output of an unsupervised learning algorithm is typically a set of discovered patterns, groupings, or clusters that reveal underlying structures in the data. Unlike supervised learning, there are no correct answers provided in advance. Instead, the insights generated are entirely data driven, helping to uncover trends, segment populations, or reduce data complexity for further analysis. We'll see the types of. So this is what I have said. The raw data algorithm and the output. Next, the types of unsupervised learning types. Clustering. First one is the clustering. Clustering is a function of technique, the fundamental techniques in unsupervised learning that involves grouping similar data points into clusters. The algorithms analyzes the features of the data and organizes them into groups such that data points in the same group are more similar to each other than those in other groups. This technique is often used when we want to discover natural groupings in data without prior knowledge of the labels. And k-mean is a widely used clustering algorithm where the data is grouped into k clusters and each data point is assigned to cluster with the nearest mean. And DB scan, density based spatial clustering of applications with noise. I'll tell you one: density based spatial clustering of applications with noise works by finding dense regions of data points and is good at identifying clusters of arbitrary shapes. Hierarchical clustering, The next type is hierarchical clustering builds a tree of clusters either by merging smaller clusters into larger ones or by splitting larger clusters into smaller ones, which is useful for analyzing data at multiple levels. And clustering is applied in areas like customer segmentation, where businesses can target different customer groups based on behavior, or in image compression where the similar pixels are grouped together to reduce the image size. Next type is the dimensionality reduction. Dimensionality reduction technique aims to reduce the number of input features while preserving as much as meaningful information as possible. This is especially important when dealing with the high dimensional data, which can be computationally expensive and harder to visualize. Next, PCA, Principal Component Analysis, is a technique that transforms the data into new coordinate system where the axis principal components are ordered by the amount of variance they capture. And T is an T distributed stochastic neighbor. T distributed stochastic neighbor ensembling, that is neighbor ensembling. What it will do is and UMAP, that is union manifold approximation and projection, are nonlinear techniques particularly useful for visualizing complex data sets in 2D or 3D. The main applications is used where it has been used. Dimensionality reduction is commonly used in processing steps where it helps remove noise, speeds up machine learning algorithms, and enables visual analysis of high dimensional data like gene expressions or image features. Next, association rule mining. The third type is association learning is a method used to discover interesting relationship associations or dependencies between variables in large data sets. It is not about predicting a target variable, but rather than about uncovering how items or features co-occurs. The a priori algorithms identify frequent item sets and then derives rule from them, such as if a customer buys bread, they are likely to buy butter. The Eclot algorithm is another approach that uses depth first search to find frequent item combinations. This method is widely applied in market based analysis where the retailers analyze shopping behavior to design promotions and optimize store layout. It's also useful in web usage mining and bioinformatics for pattern discovery. Next, anomaly deduction, that is outlier deduction. Anomaly deduction is the process of identifying rare items, even or observations that differ significantly from the majority of data. These outliers can indicate critical incidences such as fraud, structure defects, or system failures. Isolation forest works by randomly participating the data and measuring how easily a point is isolated, while one class SVM models the boundary of normal data and flock deviations. Auto next. So autoencoders, particularly in neural network, can also be used to reconstruct data and identify anomalies based on high reconstruction errors. This technique is crucial in fields like fraud detection, where the rare transactions may indicate theft, or in health monitoring, where the unusual sensors reading might significantly signify the equipment malfunctions. Next, autoencoders, neural network based. These encoders are a special kind of neural network designed to learn a compressed version of the input data known as encoding and then reconstruct the original data from this encoding. The network typically consists of an encoder which compresses the data and a decoder which reconstruct it. They are particularly effective for unsupervised feature learning and noise removal, where the model learns to extract key information while ignoring relevant noises. And autoencoders are also used in anomaly detection, where abnormal data points results in poor reconstructions and higher order. Autoencoders are widely used for image compression, denoising, dimensionality reduction, and pre-training layers in deep learning methods. Hope all have understood about the basic concepts of unsupervised learning. The remaining things we'll discuss in the next lecture. Thank you.